This is a brief introductory presentation of an alternative to current water management frameworks. The aim is to introduce the starting concepts of sufficiency in Sequity theory with reasonable decision-making processes. A couple of the references are given here. The second one is a condensed paper that is available on my website. Public policies, such as water policies, should obey certain basic principles such as sustainability, stakeholder involvement, rule of law, equity, and efficiency. Here, sustainability, such as sustainable policies for proper management of water systems, embodies almost all these principles. So, let us be clear about it. Sustainability means balancing social, economic, and environmental needs of a water system. All these dimensions must be integrated into making decisions, into coming up with a solution. There are many details that go into these three needs. For example, the social dimension must also include the political considerations. It should be realized that there are two broad and interconnected types of water systems. One is called a water use system, and the other is a water resource system. These videos are about the management of water use systems. Such an explicit distinction makes a difference, as will be seen. Now, a water use system has three pillars: water quantity, water quality, and water benefits, which are the values that a system gets from a combination of the first two pillars. These three must somehow be integrated in coming up with a proper water management. Let us briefly look at the methodologies and approaches that are being employed for the management of a water use system. Probably the most famous one is the Integrated Water Resources Management. Let us look at the name itself and ask two questions. First question: this approach integrates what? Currently, it integrates water with many other domains of human activities: land, ecosystems, energy, food, etc. In such an integration, water is not and cannot be a priority, even if the objective of the analysis is water management, because political and economic realities have given priority to the other systems. Second question: is integrated water resources management an approach to manage water uses or water resources as the name says? There is no clear distinction in this approach, which can lead to flaws. However, the outline being developed here, explicitly the priority is given to water management of a water use system. In doing so, it is crucial to understand three pairs of the ideas and their integration: adaptation and mitigation, supply and demand, descriptive and performance. These promote solutions, for example, to reduce or eliminate water poverty, water scarcity, and water pollution. The first pair of concepts of sufficiency in Sequity is adaptation and mitigation. Adaptation refers to the measures taken to manage the limited availability of appropriate water. This means that a human activity is a function of water, H function. Such a management, an adaptive management, must promote, as its priority, sustainable development of the scarce water itself in space-time. Mitigation, on the other hand, refers to the measures taken to reduce the underlying causes of water scarcity, such as food production and other economic activities, climate change and population, G function. Considering sustainable development, and using C to mean variables in society, economy, and environment, mitigation defines water system as a function of other systems, G function, and adaptation defines any other system as a function of water system, H function. In this context, we equate H to sustainable equity or Sequity, which means a fair share considering the water needs and the ability to use the water efficiently. This is a fundamental definition in adaptation, as will be recognized. The second pair of concepts of sufficiency in Sequity is water supply and demand, or water in and out. Consequently, these two different water quantities of a water use system must be distinguished. First one is called water use, which is total water supply, or water inflow, or water input. Second one is called water consumption, which is part of water demand, or outflow or output. Water consumption is defined as the amount of outflow that cannot be reused by the same water use system during a time interval. Examples are e.g., water transfer out of a water use system, water consumed to produce meat, food, and other products. Let us continue with water quantity. The generic schematics of any water use system is as you see, and it has 9 water path types. For inflows, the reds, and 5 outflows, the blacks. VU and VD are the waters in the source, in this case a river. PP is total precipitation. OS is water from other sources, such as groundwater. ET is evapotranspiration, which is a consumptive water. NR is other consumptive waters. RP and RF are the returns. The equalities on the right-hand side are easy to follow. There is one assumption about the last equality. Total inflow is equal to total outflow. This is water balance and only happens during a time interval, such as a year or a plant season, that safely can be assumed that change of storage of water use system is negligible. This is a common assumption in almost all frameworks. The third pair of concepts of sufficiency and sequity is descriptive or performance. Almost all the studies in the world focus on the description of a water use system, which is, of course, important. Here we focus on the performance of a water use system, which has received less attention. We define two types of performance measures: aggregative and distributive. Briefly, for measuring the aggregative performance, the Sefficiency, Sustainable Efficiency, Index of a water use system is developed, as will be seen later, with a target of 100%, which, of course, never can be reached. For measuring the distributive performance, Sequity, Sustainable Equity, was developed. I already defined it, and here let us take a brief look at its targets. They are defined as the maximum and minimum values of an indicator of interest for the adequate functioning of the members of a water use system, such as a household, a factory, or a farm. This indicator of interest, most of the time, is defined as to be the amount of water allocated to a member of a water use system in a period of time. For example, what is the minimum and what is the maximum amount of water that should be allocated to a factory, a neighborhood, or a farm? The complexity of Sequity will be dealt with in its own presentation. Reasonable decision-making will have its own explanations. It is enough to mention that at least the information given here should somehow be integrated. It is complex, but reasonable decision-making is being done every day all over the world in courts and tribunals. Sustainable water management has various dimensions, such as sufficiency, sequity, and reasonable decisions. These are available as PowerPoint presentations in my website. Their YouTube videos or other kind of information will also be available. Thank you.